New York's subterranean sewage system is a labyrinth so vast that it defies comprehension. The underground network comprises 7,500 miles and sends up to 3.5 billion gallons per day to the city's 14 massive water recovery facilities, where the sewage is treated and then returned to the cycle, whereas solid waste, formerly referred to as biosolids, is loaded onto trucks, barges, and freight trains to be shipped off and used as non-food fertilizer at a rate of about 1,200 tons per day. Some estimates suggest that moving this amount of byproduct requires a fleet of 55 trucks, which is perhaps an unexpected effect of every toilet flush. But there's another catch. This massive labyrinth wasn't built all at once. It was stitched together over 2 centuries, meaning when a pipe bursts or a clog forms, navigating the dark isn't just difficult, it's an archaeological puzzle. In fact, until very recently, workers had to dig through actual archives of hand-drawn 19th century maps to hunt for forgotten infrastructure. We're talking about sealed Civil War-era tunnels, diverted streams, and road connections that, for all practical purposes, have vanished. In other words, this reality suggests that the city itself might not fully understand the nature of its own engineering. So how exactly does America's biggest city handle billions of gallons of wastewater every day using a crumbling 200-year-old network? And where exactly does all that waste end up? Stay tuned to find out as we explore the unique story of New York's sewer system. I'm your host, Ryan Sokash, and you're watching It's History. By the early 19th century, New York had transformed from a colonial outpost into a global trading juggernaut. Accomplishments such as the 1825 completion of the Erie Canal or the onset of the Industrial Revolution had effectively turned Manhattan into the gateway to America. From there, the city enjoyed an economic boom that attracted over 200,000 people to the narrow streets of Lower Manhattan, making it one of the most densely populated places on Earth back then. Yet, there was a dangerous problem. The city still didn't have much of a sewer system, and in the midst of that type of population growth, residents were sitting on a biological powder keg. Initially, some of the waste was contained by night soilmen, a concept born from the marriage of urban desperation and agricultural necessity. This circular economy rested on the fact that human waste is rich in nitrogen, so it's a commodity to rural farmers who could use it as a fertilizer. A practice that dates back to ancient Asian cultures and, as you'll see later in this video, still goes on today. Furthermore, it should also be said that in the 19th century, these workers were a shunned industrial class, subject to strict legal mandates requiring them to work only between sunset and sunrise. The idea was this way they could spare the public from miasma, or the smell of their labor. Even so, they were an asset, as they were the city's invisible filters, shoveling thousands of tons of waste into their honey wagons for shipment off to Long Island farms. However, the waste that couldn't be sold, and there was a lot of it, was simply dumped into the nearest waterway, turning the city's waterfront into a fermented sludge. The challenges were lethal because at this point, New Yorkers still relied on shallow backyard wells for drinking water, so the porous soil allowed that cesspool in the bay to seep in and contaminate their supply, bringing us to the point that the city reached a series of catastrophic cholera outbreaks, proving that the night soil system was no longer a viable way to manage a growing metropolis. Now, the scale they went to solve this fresh drinking water issue was monumental. The industrial push began in 1842 with the completion of the Croton Aqueduct and the construction of reservoirs throughout the city. While these massive works of urban infrastructure indeed solved the thirst problem, they also inadvertently exacerbated the sewage crisis. Basically, for the first time, New Yorkers had enough water to install water closets, toilets, but that waste had nowhere to go except for the primitive street gutters, a state of affairs that was obviously disgusting and unacceptable to everyone. And so between 1849 and 1902, the city underwent a frantic engineering overhaul. The first integrated pipe networks were laid, initially using egg-shaped brick sewer designs to maintain high velocity and prevent clogs. And one curiosity of this era was the lack of traps or ventilation in the pipes, since without them, sewer gases often drifted back into homes, leading to a popular Victorian-era myth that bad smells, miasma, rather than bacteria, caused disease. Even so, by the time the various boroughs consolidated in 1898, the city had transitioned from a manual collection service to a massive, gravity-fed subterranean machine. And while the brick sewers of the 1800s had successfully cleared the streets of waste, they didn't completely solve the bigger problem. Rather, they just moved that problem to the shoreline. By the turn of the century, the harbor was essentially a giant open-air cesspool, and the stench was so bad that it was detectable by passengers on incoming ocean liners, miles before they docked. In that context, New York sewage was an embarrassment to the country. So, in response, the city formed the Metropolitan Sewage Commission. Their job was to investigate the water quality, and their findings were horrific. They discovered that the harbor's natural tides weren't flushing the waste out to sea at all. Rather, the sewage was sloshing back and forth with the tide, creating a permanent ring of sludge around Manhattan. Additionally, New York wasn't the only culprit. New Jersey was also dumping tons of waste into the water, causing the two states to fight over who had the most right to dump. And all the while, the region's world-famous oyster beds were slowly poisoned into extinction. It wasn't until another series of typhoid scares and realizations that the harbor was literally dying that the city finally took conclusive action. In 1929, the city charter was changed, finally bringing the 5 boroughs under a single, unified industrial command. The real engineering revolution began in 1937 with the opening of the Wards Island wastewater treatment plant. With that, for the first time, the city wasn't just moving its waste, it was treating it. This facility was a marvel of its era, utilizing activated sludge technology, essentially using air and bacteria to break down waste. Then, throughout the 1940s and 50s, as the city's population crested towards 8 million, engineers began boring gigantic interceptor sewers. These were essentially the freeways of the underworld, massive tunnels up to 15 feet in diameter that wrapped around the island of Manhattan and Brooklyn. Their job was to intercept the antiquated 19th century pipes before they hit the river and redirect the flow to new plants like Owl's Head and Newtown Creek. However, even as these plants rose, a massive flaw remained: the combined sewer overflow. Those early pipes carried both rainwater and sewage, so every heavy storm would overwhelm the system. Which is why, even after the treatment plants went online, wastewater was still being dumped into the river. The crisis reached a breaking point in the 1970s. After centuries of abuse, the harbor was biologically dead. The government responded with the Clean Water Act of 1972, a federal mandate that forced New York into another construction frenzy. In particular, the North River Wastewater Treatment Plant was completed in 1986, and it was unique, since the city built the 28-acre facility directly into the Hudson River on 2,300 massive concrete caissons. And it's an understatement when I say that some of the residents weren't too satisfied with this. To make the industrial giant more palatable to the neighbors, the city topped it with the Riverbank State Park, complete with amenities like a swimming pool and a skating rink. Anyhow, by the late 1980s, the city finally reached the milestone that it had always wanted. For the first time in its history, 100% of its wastewater, from dry weather at least, was being treated. To handle the rainwater, the city began constructing the first of its massive underground holding tanks, such as the facility in Red Hook. These are essentially hidden cathedrals of concrete, capable of holding millions of gallons of stormwater mixed with sewage, until the plants have the capacity to process it all. By 1990, New York had successfully reclaimed its harbor, and fresh water was being pumped back into the cycle by the billions of gallons. Nevertheless, yet another challenge arose, though this one is less obvious. With 100% of the waste now being captured by the system, the city suddenly had thousands of tons of solids to remove, and on a daily basis, a reality that, in my opinion, brings us back full circle to the concept of those Victorian night soilmen. The process of extracting solids begins in the primary settling tank of the city's 14 recovery plants. Here, the gravity does the heavy lifting. The flow is slowed down, allowing heavier solids to sink to the bottom. This raw sludge is then pumped into the city's most ironic infrastructure, those famous digester eggs at the Newtown Creek facility. These 8 stainless steel clad vessels stand at 140 feet tall and can hold up to 3 million gallons of wastewater each. Inside, the city maintains a temperature of exactly 98 degrees Fahrenheit for bacteria to do its work. Depending on the proportions of rainwater to sewage, it can take anywhere from 15 to 30 days for the microbes to eat the waste, reducing its volume and producing methane gas, which is then captured by the city to heat the facility. Once that phase concludes, the city is left with a byproduct that is still 95% water, and hence it's too heavy to transport. To solve this problem, the sludge is then sent to a dewatering facility like the massive plant at Ward's Island. Here, the waste is fed into a giant centrifuge that spins at thousands of revolutions per minute to squeeze out the water. What emerges is a dense, earthy material with the consistency of wet soil, known in the industry as cake. Every single day, the city produces approximately 1,200 tons of this cake. And since the city has no space to store or bury it, a complex logistics plan has been implemented for its removal. While a portion of the waste is moved by specialized sludge boats, the majority is loaded into sealed containers for long-haul transport across the country, where it's further sold for agricultural use. And it's strange to consider that the waste of a New Yorker might end up as fertilizer for a commercial forest in the Appalachian Mountains or used to reclaim an abandoned strip mine in the Midwest. According to some sources, one of the most significant recipients of this waste has been ranches in Texas, which for years received thousands of tons of NYC biosolids via sludge train to fertilize desert grasslands. Today, this export marks the end of a cycle. We have moved from dumping raw sewage into our own drinking wells to a system that captures, digests, and transports that same waste across state lines to grow future forests. In the modern day, this magnificent system remains a patchwork of eras. Its 7,500 miles of pipe and various features require an army of nearly 6,000 employees to operate. In certain parts of the city, workers still maintain functional brick sewers that were laid when Abraham Lincoln was a young lawyer. And for decades, crews struggled to navigate them physically, as the spaces are so tight that they can barely stand and the maps were not always up to date. However, as of 2026, that archaeological puzzle is finally being solved by digital innovations. After nearly 2 centuries of relying on fragmented paper-based records, some literally stored in cardboard tubes, New York City has launched its massive 3D underground program, which is basically a unified digital scan of the city's entire subsurface. Hence, for the first time ever, those 19th century tunnels and vaults are being mapped comprehensively. And that, my friend, is where the waste of New York goes. I really hope you enjoyed the episode, and if you did, please consider supporting the channel by hitting subscribe. Otherwise, until next time, I'm Ryan Sokash, signing off.